Good afternoon, everybody. Hope everybody's well, staying dry. It's a rainy day here. I don't know what it's doing in Columbus, but it's a rainy day here. All right, we're going to look at pedigree today. So while we're waiting for everybody to come in, if you would go to Canvas and read over this section. All those little puppies look so cute. They're all cute until they grow up, and then they're big dogs and make big messes. Any of y'all have a dog that's, or mostly dog that I have a pedigree? Mhm. I'm gonna give it another 5 minutes and then we're gonna go ahead and get started. All right, while we're waiting, also a reminder that fifth period exam is Monday. So we don't really have a lot of time to review. So make sure that you are going over your notes for this unit. So again, your test is going to cover cell reproduction and genetics. And I'm going to mostly focus on meiosis and mitosis, not so much all the other reproductions. Okay, so we've already had the test on this one, but I'm going to focus on mitosis and meiosis and genetics. Everything except for we have not done karyotyping yet. We'll do that after the test. Okay, so everything up to pedigree we will do. Since we've not tested this before, most of the tests will be on these questions, but a couple of questions will be on mitosis and meiosis. Alrighty. I had more people. Some folks disappeared on me. Zoom has been acting a little strange. Folks are in and then they're out. And I got to be checking to see. Like I said, and in this class, some of the folks will keep coming late. So I'm just going to get started and they're just going to miss it. We're not going to keep waiting for them to come in when they feel like coming in. It's not fair to those of you who come on time. And I do appreciate y'all. All right. So pedigree, back to pedigree. So please do look at that. I think most of you have heard the term pedigree before, and you know that it has to do with breeding, and we're looking at certain genes. It's certain, especially with dogs and horses. They look to breed a certain line. If they like the way the characteristics of this dog or this horse, they try to breed it with like characteristics so that we keep getting the same kind of dog or horse. Okay. So that's the breeding part. The pedigree is actually a way of displaying what these traits are, who has them, and what the next generation will look like. So we are going to practice doing a pedigree chart. And there are some rules. I'll tell you what, we'll go ahead and watch the video while we're with other folks. I'm going to keep track of who's coming in late, but I'm going to go ahead and start the video.
The crystal blue waters of Wrightsville Beach will take your breath away, even before you dive into world.
So I have a really awesome picture for you. Here it is. Oh, it might look like circles and squares to you, but make no mistake, this is no ordinary picture.
All right, I'm going to pause it. You all might want, whoa, did not pause.
Hi, everyone.
Oops.
Increasing energy resilience.
I hit the wrong button.
Actually already happening step by step.
What did I just do? All right, I hit the wrong button. I don't know what I just did. Oh, it's coming. I was trying to pause it, and instead, I'm gonna pause it there. All right. I forgot what I was gonna say. There are some rules of doing this, so you need to pay attention to what the squares mean, what the circles mean, what an empty circle or square means. Those are the rules that you have to pay attention to. And then some with a line going through it. Okay, so that's what we're going to be focusing on. What are the rules for drawing pedigree?
So I have a really awesome picture for you. Here it is. Oh, it might look like circles and squares to you, but make no mistake, this is no ordinary picture. This is a pedigree. A pedigree is like a family tree. It can show information about an inherited trait passed across generations. And this one is actually a small pedigree of us. Well, our human forms. See, that's me, my sister, my mom, my dad. I'm not arbitrarily picking random shapes to represent us either. In a pedigree, the circles represent females, squares represent males. One way you can remember that is the letter C for circle comes before the letter S for square in the alphabet. Alphabetically, the letter F for female comes before the letter M for male. I've got to think about letters of the alphabet, though. I realize that might not work for everyone. So if we take a look at this pedigree, these Roman numerals represent generations. There's 2 generations here. This between my parents is called a marriage line. This line here connects parents to children, so you could see there are 2 children from this marriage. Now you may wonder, why are some of these shapes shaded? What does that mean? Well, the shaded shapes represent a trait that is being tracked in the pedigree. Here are 2 important facts about the particular trait I am choosing to track. Fact number 1 about this trait being tracked is that it's recessive. Recall that in typical Mendelian inheritance, dominant alleles, if present, will lead to the expression of dominant traits. Recessive alleles only are expressed when the dominant allele is not present. Now, fact number 2 about this trait is that it is an autosomal recessive trait. Just a reminder that autosomal means a chromosome that is not a sex chromosome. In human body cells, there are 46 chromosomes. The first 44, 22 pairs, are autosomes. The last 2, 1 pair, are sex chromosomes. So this trait is not sex-linked since it is autosomal, and that means it does not need to be written as coefficients on the sex chromosomes. So what is the trait we're tracking? Attached earlobes. Yes, you might not realize it, but look around and you'll see that humans, they have free or attached earlobes. Although we want to point out that there may be more than just these 2 categories for earlobes. And while this example is used often in basic genetics, there's probably more to this than just one simple gene. For our example, let's assume a simple gene trait, and that free earlobes is dominant, meaning at least one dominant allele must be around. Attached earlobes is recessive, showing when no dominant allele is present. So if we were to put the genotypes next to each of these shapes, what would they be? Well, the shaded ones would be easy, because we just mentioned that attached earlobes is the trait we're tracking, and it's an autosomal recessive trait. So if we use the letter E, then these shaded shapes must be lowercase e. Any capital dominant letter, and the individual would have to have free earlobes and not be shaded. So let's look at individual 2 in the first generation. That's our father. He's not shaded, so he can't be little e. What about big E? Well, there's a problem. See his children? Us. Each child must get an allele from each parent. So if I received a little e from my mom, then I had to get the other little e from my dad. Therefore, he can't be big E, or he'd have no little e to give. His genotype must be the heterozygote genotype, big E, little e. He's what we call a carrier, though. He still has a phenotype of free earlobes because of that one capital, but he carries the lowercase allele. Now, that's just one tiny pedigree. Let's look at a big family reunion. Well, an imaginary one, because I have to confess, I don't really know whether our relatives have free or attached earlobes. I thought about sending a survey to them, but it just felt a little awkward. So here we go. Big, giant, imaginary family of relatives. Okay, just to make sure you understand this, how many siblings does my dad have? Well, look, here's my dad in generation 2, number 4. He has 3 siblings, all brothers, right here. What is the phenotype of my paternal grandfather? Well, look, here's my dad. Here's my dad's dad. That would be my paternal grandfather. And because his square is shaded, that means his phenotype is attached earlobes. Okay, so let's go ahead and label all these shaded shapes with the genotype little e, since we know that's the trait we're tracking. Now take a look at generation 1, individual 1. That would be my paternal grandmother. What's her genotype? We know it's not little e, or her shape would be shaded. But if we went with big E, could that still work? Yes, all the offspring could get a big E from her and a little e from my grandfather. But what about big E? Would that work too? Yes, because the children could still get a big E from her and a little e from my grandfather. It may be less of a probability, but it's possible, and therefore we must list both, that she is a big E or big E, because we don't know. All the offspring of my paternal grandparents, though, they're going to have to be big E. Remember, they have to get an allele from each parent, and that means they're going to have to pick up that little e from my grandfather. They will be heterozygotes, and that's the only option here. Pause this video and try to solve the right side of this pedigree now. Ta-da! Imaginary family done. So how'd you do? Well, here are some of the
She
tricky
didn't give
ones.
me a chance to
Did
pause
you
it.
see that generation 1, individual 4, has to be a carrier only? Because if not, then the shaded individual children would not be able to get the little e that they have, because they have to get a little e from both parents. How about individual 9? This female married in, but that's not the reason that she can be either big E or big E. If you look at the children, they aren't shaded. So while they will have to get a little e from number 8, as that's all number 8 can give, the other capital letter can be obtained from number 9 regardless of whether she's big E or big E. Remember, one option may be more likely, but if it's possible, you need to include both. Now, remember how we made a big deal about how this was an autosomal pedigree? Well, what if you're dealing with a sex-linked trait and therefore a sex-linked pedigree? There are a lot of sex-linked recessive traits. Color blindness and some male patterns of baldness can be sex-linked. Let's pretend now that we're told this is a sex-linked recessive trait. I'm going to keep the old labeled pedigree here that showed an autosomal recessive trait just for comparison, but now here's a brand new sex-linked pedigree. First of all the females, the circles, should have an XX to indicate 2 X sex chromosomes by them. Remember, females have 2 X chromosomes. Males should have an XY to indicate an X and a Y sex chromosome. That's always a good thing to do first. Now remember that we were told this pedigree is tracking sex-linked recessive traits. So the shaded one here has the sex-linked recessive trait. A reminder from our sex-linked video about how this works. Let's use the letter R for an allele. Now recall that females that do not have the trait, they can be either this or this, and the heterozygote genotype, this, is a carrier. She doesn't have the trait herself because of the dominant allele, but she's carrying it. Only a female that is this will have the sex-linked recessive trait. So if I'm looking at this pedigree, what would the genotype for individual 1 in generation 1 be? Well, notice here she has 3 children, and one of her sons here is shaded. Where does her son get his Y sex chromosome from? The father. Where does he get his X sex chromosome from? His mother. Individual 1 doesn't have the trait, or she would be shaded, but she must be a carrier if her son received an X chromosome with a recessive allele on it. Now, what about individual 2 in generation 2? Well, she can be this, like her mother, but look, she could also be this, because it's possible to get one of those from each parent. If it's possible, you must include it. Now, pause the video and try the last female. How'd you do? Remember, the key here is to always check and make sure that when you look at a child, they have to be able to get one of their alleles from each parent. Now remember that both of these examples were recessive. It doesn't have to be that way. On our handout, you can try one that follows an autosomal dominant trait. If it's a dominant allele that you're tracking, remember it would only take one dominant allele for a person to have that trait. Another quick thing to point out is sometimes you will see pedigrees that are have shaded. Well, that's just awesome because they're basically letting you know that the have shaded ones are carriers. If I wanted to turn our first one into that have shading, then it would look like this. Mapping and understanding pedigrees is important, especially as we continue to make advancements in understanding how genetic disorders are inherited. Well, that's it for the Muba Sisters, and we remind you to stay curious.
Alrighty, so I'm going to do attendance, and I want you to keep looking at pedigree, but also we're going to download a worksheet, and we're going to go through all of those things on the worksheet. So read this. Look at what carriers are. I'm gonna come back, and this is a very famous pedigree. So we're going to go through that, and then we're going to look at the worksheet. Okay? Harry Potter pedigree. All right. So I'm going to do attendance. I'll be right back. Read, read, read. Learn what all of these symbols mean. That's important. Okay? All right. Those of you who were late, we are in Canvas under pedigree. What is pedigree? Yeah. Okay, I'm back. Only some of you were reading as instructed, others were just sitting around doing nothing. All right. Also, while I'm at it, make sure you get caught up on your grades. Next week is a 9-week test. That also means that 9-week progress reports follow. So you need to make sure that you are caught up in all of your missing assignments. Um, Tomorrow is tutorial at 1:35. So if you need help, you need to show up to tutorial. All right. So again, the pedigree is a chart. It's a graph. It illustrates genetic inheritance and generation. So the trait being passed on from one generation to the next. Okay. They gave you the rules that males are always a square, females are always a circle. If you're tracking a particular trait, we shade that box in if the individual has that trait. And when we do pedigrees, we're always looking to track a particular trait. Okay, they have a line through the ones that are deceased. And as she said in the video, sometimes they shade it half if they are carriers. Okay, like this one, we're just going to talk about a carrier. All right, again, autosomal means that it's carried by regular body cells, like your eyes, your ears, your skin, your liver, all those kinds of things. Sex linked means it's attached always to either the X or Y chromosome. So make sure you know the difference between autosomes. If it is dominant, if it's recessive, it's going to be a lowercase letter. If it's dominant, it's a capital letter. In sex-linked characteristics, the trait is usually a recessive characteristic, which means if the person is normal, they can be hiding that trait and it won't show up. It'll only show up if the if it's a girl or the mom doesn't pass on the X chromosome with that trait. All right, so it's like here, they gave you shaded ones. Carriers are usually represented by like these squares have shaded, the mother has a shaded. So this one, the parents both are carriers. That means both of them have the capability of passing it on to their offspring. All right, I'm going to back up here just a little bit. The other thing that you need to know about this that you talked about is these lines. What do these lines represent? Because you're going to have to follow the line. All right, so the line that's horizontal means that those two are married. The line that's vertical means that's going to the next generation. So it will be connected by the next bracket. So the parents are usually what we call the first generation or F1. This is, I mean, the parent generation. Then we have the first generation offspring. Then we have this one shows the second generation of offspring. Okay, now notice this line. So this line from the original parents only goes to 4 of these individuals in the next generation. That means that's their children. They had 4 children. So if you follow this line, they had one male who's affected. They had one female who is now deceased. And they had, according to this chart, and they had another male who was affected by the whatever characteristic, and their line indicates that they are now deceased. And they had another son. So they had 3 sons and 1 daughter. And they have lines connected to them, said all 3 of their children, 4 of their children got married. Okay, all 4 children got married. And then they had children. So that's what each one of those has a line descending to the next generation. They had this, the first one, the first son married someone, and it looked like the whole of the first set of offspring, they have passed away. And now we're looking at this next generation. And they had 3 children. None of them are married yet. So they had 2 boys and 1 girl. One of the boys is affected by whatever characteristic they were tracing. The daughter got married, had 2 children. The male child is affected by whatever disease they're tracing. The daughter is fine. Over here, they had a normal son, normal daughter. Over here, they have an affected male and a normal daughter. Third offspring of the first set only had 1 child and they were normal. Fourth set, the son and his wife had 3 children. 2 of the sons born to that group are affected and 1 of them has passed away. Okay, so you see how I'm able to read this chart just by using the key down here at the bottom. Most of these activities will give you a key, so you'll know what the shading means. So this one says the males and females are represented by the different shapes. The mating represents by a horizontal line. Offsprings are represented by vertical lines extending down from a mating. Children are listed in birth order from left to right. And an affected individual who carries the express trait will be shaded. Okay. All right. So not only are they going to be shaded, they're going to have half boxes. So half boxes means they are a carrier. They don't have the trait, but they're a carrier. All right. All right. So the famous pedigree line is the kings and queens of Europe have this tendency to had a tendency to have hemophilia. We talked about that yesterday. All right. So we start with Queen Victoria. She had hemophilia, and she passed it on to all her sons, and then they got married and they passed it on. So you had several generations of, and look at these are males. All the red ones are males. They had some of the females were carriers, they're the pink ones, but the males passed on hemophilia. This is what now? What? 1, 2, 3, 4, 5 generations later. Okay. All right, we're going to look at what time is it? Okay, we're doing good, doing good. I'm gonna look at a worksheet. Kind of has all that information on the worksheet as well. So if you go to the next slide in your Canvas and download this worksheet. Oops, why did it do that? because I hit the arrow and not the. All right. So this has the same information on it. So the first part of the worksheet is just the rules and regulations. I notice, and then they have an additional thing here. They indicate how you show twins. Okay, so again, male without the trait is a square and it's blank. With the trait, it's going to be shaded in. Females are circles. With the trait, it's going to be shaded in. Okay. All right. All right, so the first one that they're giving you here is a pedigree showing blue eyes. So what they're saying here is this male does not have blue eyes because it's not shaded. This female has blue eyes because it is shaded. Okay, they had 3 children. The first one was a girl and she has blue eyes. Second girl, no blue eyes. And a boy, and he does not have blue eyes. The blue-eyed girl got married and she had a son and he's got blue eyes. Okay. All right. So they give you this generation 1 is the parent. So you look at this Roman numeral over here is generation 1. Generation 2 represents the parents and the children, and the one that got married is the son-in-law. You know, he's a son-in-law because it's got a square. All right, generation 3 represents the male grandchild. So these two did not get married, so there is no, the only generation 3 individual is this one individual over here. Okay, all right. The colored in symbols have a genotype of little b because blue eyes is recessive. Brown eyes is dominant. So we're going to have 2 little b's. All right, the non-colored symbols have at least 1 capital B, but they probably have a recessive B as well, like she was saying in the video, because the only way that the children can pick up that gene is if they got it from their parents. Okay, the second allele for brown-eyed might be able to be determined by the parents of the children. All righty, that's the first one. So that's, you didn't have to do anything with this. All you had to do, this was just giving you information. This one they did for hemophilia. Okay, and this is kind of what we did with our Punnett square, but so now we're drawing it as if it were a pedigree chart. All righty. So again, they're looking at, look this over and I'll be right back. I have to step away. All right. Oh, look who finally came to class. All right. So on this one, if you were reading this, again, we have to not only look at are they male and female, but we're looking at what gene they're carrying. Okay. So again, the hemophilia is going to be represented by a shaded. What is locked? How is it locked? Your worksheet is locked? Oh, how is the worksheet locked? Okay, hold on. Sorry about that. Let's see what is it's published. It's available today. Today. Oh, why does it that's why it's locked, because it says February. Sorry about that. Why does it save? Not, I mean, this is February, it says March. Okay. Sorry about that. Wow. Okay, available today. And it's going to be available. That's what happened. All the rest of those dates can say, but this, because yeah, all the rest of the dates are good. It's just this available date was bad. All right, refresh your page and try again. So sorry. Glad I left it up. Nice of you to join us, Isaiah. All right, we good? We good. Sorry about that. I don't know how that happened. All right, so we went over that first part, and now we're looking at the hemophilia part. All right, so we've got two sets of people here. So we've got maybe grandma and grandpa over here, and then grandma and grandpa over here. And then they had, this first one set had 3 children, and they all seem to be normal. None of them have hemophilia. Okay. Only the third son, remember they're listed in order, so this would be 1, 2, 3. The third son got married, and she seems to be normal because she's not shaded. And they had a son, and he seems to be okay because he's also not shaded. However, this second group over here, they had 4 children. So the person that he married came from this set of parents over here, and she was the first of 4 children. And there was a son, another female, and they seemed to not have hemophilia. However, the son over here had hemophilia. And when they got married, actually, no, okay, I backed that up. This is the person they married, because they're not connected. So they had 3 children. Okay. The son married this young lady here, and then this one had hemophilia. All right. So we have to figure out, they probably didn't have the gene for hemophilia, but this set of grandparents did. Okay. Because these two cannot have hemophilia if they didn't get it from mom or dad. Actually, they had to get it from mom because dad doesn't have hemophilia. So his X has to be normal. It's going to be X and Y. So this female had to be carrying this version. It's highlighted on the worksheet, but she had to be an X with a little h, because that's the only way that she can pass it on to her son. Okay. And when he married, she can be normal. So he probably got she had to be a carrier, because even though she's normal, she could be getting the X from X from mom and the Y from dad in order to be a male. Y had to come from dad, X had to come from mom. So she was a carrier. He married a carrier. Okay. All righty. Now your job. So all of that was just information up there. So you just keep reading it and go over that. Thing that you have to do is they got a little Harry Potter activity. All right. So again, they've given you some information about who does what. And then you have to answer. You have to read this chart to figure out what they're asking. What is the relationship between, so they tell you the first one, between number one, they're all number. What is the relationship between 1 and 5? Okay, 1 is a circle, that's a female. There's a line connected. This is a male. So that's mom, that's the son, and that's what you write here. So all you have to do is look at this chart and figure out what is the relationship between the lines that are connected. Okay. And then you have to answer how many grandkids and the family pedigree. Let's just try to get, in the time that's left, let's just try to get that part done. Okay. Everybody's working on this one right here, just up to there. So the first one is done for you. And up top, they give you explanations of what you see. So if you need to go back and reread it, go back and reread it. All right, I'm going to stop sharing for a minute and check y'all out on Google Guardian. See that everybody's practicing. Practice makes perfect. And of course, Isaiah, you come late and you're not doing it. Everybody should see a worksheet up for everybody. Everybody should be working on this. I see 3 people working on it. I don't know what the rest of y'all doing. Test is next week. It's gonna be on the test. Alrighty. For those of you are actually working on this, where'd my thing go? All right, quickly go over the answers. So number 1 and number 10. So number 1 is a female. Number 10 is in the second generation. So these are offspring. Number 1 had a son. Okay. We're looking at the characteristic of color blindness, right? So number 1 is a son. The son got married and had a child. So that makes the relationship between 1 and 10 is that 1 is the grandma to the granddaughter, because it's a circle, and they're both normal. Okay. And actually you didn't have to say what that's just all you had to say. This is grandma. Number 1 is grandma, and number 10 is a granddaughter. You do have to say whether they are male or female. Number 3 is the son. Sorry, is a daughter. No, son. I was right the first time. Is the son because it's square. And it's not the son. It is the son-in-law because they are married to the daughter. Number 4 is the daughter. Number 4 married. Number 3. So that's the son-in-law. So the relationship between, 3 and 5 is that they are in-laws. Okay, they're brothers-in-law. 3 married 4, and 5 is the son of 1 and 2. So they are brothers. Was there squares? Both are squares. They are brothers-in-law. 1 and 2, mom and dad. 4 and 5 are the offsprings of 1 and 2. Okay, that's the daughter and son from 1 and 2. And 5 and 8. 5 and 8. So 5 is the male, and 8 is the son from number 4. So that makes 5 the uncle. Okay. I don't know if I have time, but we'll try. Okay. Let's see if I can do that. Everybody. Okay. 1 and 10. So we said 1 is grandma and that's the first one. 3 and 5. 3 and 5 are brother-in-laws. Okay. Okay, 4 and 5 are let's see, 4 and 5. Sister and 5, 8. Um, there we go. All right, so all the answers are on in the chat right now to that first set. All right, and it's time to go. Nope, we got 5. We got 3 minutes. 3 minutes, 3 minutes. All right. How many grandkids do 1 and 2 have? So they have 2 children, and each of the children had 3 children. So how many is that? I know you can count. Thank you. Thank you. Thank you. All right, 6. The pedigree above is a recessive genetic disorder of colorblindness. Which individuals in the family are colorblind? So then all you have to do is put the numbers of all the shaded boxes, and notice it's all the males. All right. This is which individuals are colorblind. So that's going to be all the shaded boxes. And put the numbers in order, please. All right, in this family, the pedigree, majority of the individuals that are colorblind are what gender? What are all the squares? Male. And it is a good indicator that this disease is sex linked. The females don't have it, only the males. All right, so I did that one for you. You work on this one. And we'll talk about that Monday because it is time to go. Any questions before we go? All right. Actually, don't worry about doing this one. Study for the test. Your test is Monday. Study for the test. Don't worry about doing the second one. Okay? Study, 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 study. It's unfortunate that y'all are first. We didn't have time to spend more time reviewing, but your test is Monday. All right. Bye, y'all.